Example 14.4b is going to be a continuation of example 14.4a, where we're going to be using the rational zero theorem to make a list of all possible rational zeros of f. Again, this does not mean that everything on our list is going to actually be a rational zero, but if a rational zero does exist, it's going to be on this list. So we'll start with looking at the polynomial, and our polynomial has a constant of +2. So that's going to help us with creating the p-list. And over here on my scratch work, I'm going to think about what are all the different integer factors for 2. So that would be 1 times 2, as well as -1 times -2. Now I understand that many of you do not need scratch work to do this, but for those that would prefer to write it out, this is what the scratch work is for, so you can write it out. So certainly if you can do this in your head, you're more than welcome to do so. What I need to see is the results, which is going to be ±1 as well as ±2. For your Q list, you're going to be looking at your leading coefficient of 4 and thinking about all the combinations that go with that. So for 4, we would have 1 times 4 as well as 2 times 2. Now, there's also the negative version of all of those. Now, since this is just scratch work, I don't have to write every little detail out in my scratch work, but to accommodate that, I can just easily put plus or minus in front of each one of these factors, and that will automatically take care of all those different combinations for Q. For P over Q, we are also going to take advantage of the plus or minus nature of these factors. So I'm not really going to go through every possible combination like I did on part A, because I know the plus or minus is going to appear with each one. So that's going to cut down my workload in half by recognizing that I can just put a plus or minus with every combination. So then I'm going to focus on what are the different combinations of P and Q just with the raw value that's there. So I'm going to start with a Q value of 1, and I'm going to run through all the different P values. So that would be 1 over 1 as well as 2 over 1. Then I go to the next Q value, which is 2, and that would be 1 over 2 or 2 over 2. Now I start over again with the last Q value of 4, so I'd have 1 over 4 as well as 2 over 4. And this will be the quickest way for us to have an introductory list for the possible rational zeros. But you want to also check for redundancies and if there's any way to simplify what's taking place. So for example, simplification, I don't need to leave 1 over 1 as a ratio. I can just write it as 1. 2 over 1, same idea, just call it 2. 1 over 2 is already in a great position, call it 1/2. But 2 over 2 is a redundancy. 2 over 2 would simplify to be 1. Don't write that one down again. 1/4 is not a redundancy, but 2 over 4 is. That's just going to be 1/2. So we'll stop our list there with plus or minus 1/4, and this becomes the list of possible rational zeros of f.